1, 4. And right now we're looking at being able to graph linear and absolute value equations using a table, and being able to graph linear equation using x and y intercepts. If we're able to, we'll try to get to learning target number 3 as well. So we have 2 variable equations, and that usually has an x and a y. Most of you are familiar with tables and t-charts. We can make a table with x and y values. If we have an equation, we plug in a number for x and get our answer for y. We can also make a table vertically, or a t-chart. And our graph is a visual representation of our equation through ordered pairs x comma y. Now there are only 2 types of equations that we are looking at for right now. We're going to encounter lots of other equations in algebra. In Algebra 1, mostly we stick with linear equations and quadratics, but we will encounter other kinds. And when we do, I'm going to show you how to differentiate between whether it's linear or nonlinear. But for now, the 2 that we're looking at are what it's set up in the learning target, linear and absolute value. So it'd be very easy to distinguish between the 2 of them. For these 2 examples, which one is linear? The one on the left, yes. Okay, you see the absolute value function over here, so you know the one on the right is an absolute value function, the one on the left is a linear equation. For our linear equations, even our absolute value equations, we want to have y by itself. It just makes it easier to make our table if we solve in terms of y when we go to make our table. So raise your hand if you can tell me what my first step will be to get y by itself. Maddie. Subtract 4x, yes. Subtract 4x from both sides. This gives us 3y equals, now there's 2 ways you could write this, 12 minus 4x or negative 4x plus 12. We usually try to put the variable first, but if you have 12 minus 4x, that's okay. You'll still be able to generate your table. So negative 4x and positive 12. What should I do now? Macy, what should I do? Divide by 3, yes. Divide every term by 3, and we have the equation y equals negative 4/3 x, or negative 4/3 times x, plus 4. Now some of you already know other ways to graph this, and that's okay. If later in the class when we have graphing problems, either in geometry or regular algebra, if I just ask you to do a graph or to use a graph to help solve it, you can use any technique you want. We're going to be looking at several techniques. The first one, and the one they're asking us to use, is by graph, or by table. So even though you might know another way to graph this linear equation, this line, you're supposed to make a table to do it. One of the most important points, not the most, but one of the important points we always want to know is what is the height, or the y value, when x is 0. So we're going to make sure that 0 is on our table, and we should put some negative values and positive values in our table also. In reality, though, how many points does it take to make a line? We should, usually we're told to graph at least 3 points to make sure everything's right, but how many points does it take to define which way the line's going? 2. But we're gonna do at least 3 on here. Looking at this denominator, what should I pick as my numbers that I'm gonna put in? Something divisible by 3. So I could do 3 and negative 3, or I could do negative 6 and 6. I'm going to do negative 6 and 3. Actually, I'm going to do negative 3 and 3. It's just easier. But yes, we want something divisible by 6 to make, or by 3, just to make it easier, so we're not dealing with fractions. When you put negative 3 in, we have negative 4/3 times negative 3. That's going to be positive 4. plus 4. So positive 4 plus 4 is going to be 8. So at negative, I will graph them in a second. When I plug in 0, this becomes 0. 0 plus 4 is 4. And when I plug in 3, the 3's cancel. I have negative 4 plus 4 is 0. So my 3 points are negative 3, 8, 2, 6, 8, 0, 4, and 3, 0 are my 3 points. And then I just connect them with a line. Now this graph doesn't stop, or this line doesn't stop where my graph ends, so I have to draw an arrow indicating that the line extends beyond that in both directions. Any questions so far? Now, if you have a graphing or scientific calculator, you should be, right, we should be able to do this pretty quickly in our heads, but if we needed to verify that our math is correct, or maybe I plotted the points and said, wait a minute, that's not a line, what did I do wrong? It might be that we solved it wrong, so we want to double check that, but it could also be that we're evaluating the points wrong. So if you do negative 4 thirds, and then in parentheses your number, plus 4, it should give you the output. Now instead of having to continuously type this, in the scientific calculator you should be able to scroll up and go in and change that number to whatever you want that's in the parentheses, and that way you don't have to keep typing it. In the graphing calculator you can actually hit the second key and the enter key. So second enter, and it will retype the equation, or it'll paste the equation in for you, so you can just go back and change the number that's in parentheses. Your graphing calculator can't?
I don't know, it's not working.
I'll have to look at it. Yes. Oh, don't use the up arrow. For you, you're going to hit second enter, and it's going to paste what you just did.
Oh.
Okay, so that should work. But if you have a non-graphing calculator, you should be able to go up, and then it will let you edit it right there when you push the up arrow. Okay? All right. Now, that works great for the linear functions. We'll come back to absolute value in a second. I'm going to ask you to try letter C. You're going to want to solve for y and make a table and graph. And then we're going to look at letter D, because that's also linear. There's no absolute value symbol. And then we're going to talk about absolute value. So take a moment to solve for letter C. So there's a lot of different ways to graph this, but again, they're telling us to graph by a table. I don't care if you use this, or if you use a t-chart, or if you show with your calculations in the middle. When you solved for y, you should have gotten y equals 2x plus 4. Plugging in values, you can pick any x values as long as they're going to fit on your graph. When I put 4 in, I got 12. Doesn't fit on my graph. So I had to pick another point, 2, 8. So now I have negative 4, 0, 0, 4, and 2, 8. And somehow I plugged something in wrong. When I plugged in negative 4, oh, no, negative 4 doesn't, that's negative 8 plus 4. That's negative, wait, negative 8 plus 4 is negative 4. I have the wrong value in my table, sorry. This should have been at negative 4. All right, so now I have my line. You can, if you don't have a line, something's wrong. You either have the wrong table, so you have to check, recheck your calculations, or you have the wrong equation if the table was correct. Remember to draw your line across the whole graph and then draw arrows showing that it goes beyond those points. Now I want to talk about, are there any questions on letter C? Letter D, we have y equals negative 2. That means it doesn't matter what the value of x is. X can be negative 4 or 0 or 5 or any number. Y is always negative 2. So when I go to plot this, I've got every x coordinate has a point, a height of, no, not of 2, of negative 2. a height of -2. So it's going to give me a horizontal line. We have an expression to remember this, and we'll talk about it later as we get into some of the other things. But for now, just know that that means every output, every y value is 2. These two are not supposed to be there. The equation above, letter A, I'd like you to change to x equals 5. What does that mean? It is a vertical line, but that means that x is always 5. For every single point, when we have a relationship between x and y, the x is always 5. It doesn't matter what the y is, x is always 5. So I'm at 5, 1, 2, 3, 4, 5, 0, and 5, 2, and 5, -2. All of these points, doesn't matter what point, what the y coordinate is, the x is always 5. It is a vertical line. Any questions on that? All right, now let's talk about absolute value. So we should know how to solve absolute value. We're going to need to in a little bit. But right now we're just making a graph by table. So I want to start with, to see, we'll do this and then see if you have any observations. I'm going to make a table for this one. I'm going to make it where I show my work, because in my first hour, students weren't sure what they were supposed to do, when they were supposed to make it positive. You can get negative answers for y, because there's other stuff that happens besides the absolute value. So I picked -3, -1, 1, 3, and 5. I picked a few points, because when there's an absolute value graph, it's not going to graph a line, it's going to graph something else. So I want to have more than one point to make sure, or several points to make sure I get what I'm expecting. So when I plug -3 in, this is the absolute value of -3 plus 1. And that, the absolute value of -3, or -3 plus 1 is -2. What's the absolute value of -2? +2 minus 1 is 1. So I have -3, 1 as one of my points. For my next point, I'm going to plug -1 in for x. So I have -1 plus 1, which is 0. Minus 1 is -1. For my next point, 1, I'm going to plug in a 1. 1 plus 1 is 2. The absolute value is 2. Of 2 is 2. Minus 1 is 1. So I have 1, 1.
On a calculator, how do you put in like...
So if you have the scientific calculator, I'm not sure. I haven't figured it out. I'm going to look it up for you guys. You can try to Google it. I know if you have a graphing calculator, it's not a button, but rather a series of buttons. You have to press math, and then go to ABS, abs for absolute value, and then it'll let you put it in. So you can do 1 plus 1, and then outside minus 1. But if you don't have a graphing calculator, there's supposed to be a way, but I'm not sure. So you might want to Google it. I'll try to look it up too.
Wait, can you do that again?
Yep. Under math, so you press the math key, go to number, ABS, and it'll bring up the absolute values. And then you just have to push over for the stuff outside of it. So this gives us, let's look at our 3. I've got absolute value of 3 plus 1. Well, 3 plus 1 is 4. The absolute value of 4 is 4. Minus 1 is 3. And then the absolute value, I've got 5 plus 1, which is 6. So I do the absolute value of 6, which is 6. Minus 1 is 5. Don't be confused. You can get negative values for y. That's okay. Because as long as I do what's inside first, then I make that number positive, then I subtract 1. So I'm going to plot this. I have -3, positive 1. I feel like I'm off 1. 1, 2, 3, positive 1. -1, 1. Sorry, -1, -1. 1, 1. 3, 3. And 5, 5. Now, does this graph only have those points? No. By connecting them, I'm showing that all the points between are also part of this graph. They're also a relationship between x and y. And by extending them, I'm showing that this will continue. Okay? So what happens is we get a V shape. You should get a V that opens up or a V that opens down. We'll talk about why they do that later. But right now, I want us to look at, I'd like you to try letter B on your own, and then we're going to do letter F together and see if we can make some observations that'll help you decrease the points that you need. For letter B, just so we all have the same points, I'd like you to use -2, 0, and 2. If you have other points, that's great, but use at least those points for now. Who has an answer for the y values on this table? What happens when I plug those numbers into the absolute value? They come out positive, right? So when I plug those in, I've got, this becomes 2, but then I'm supposed to multiply it by -2. So down here, I'm going to show the work for this. I got -2 times the absolute value of -2. That part's 2, and then when I multiply it by -2, I get -4. The absolute value of 0 is 0 times -2 is 0. The absolute value of 2 is 2 times -2 is -4. So order of operations tells us we have to do what's inside of here first because it's like parentheses even though I can't distribute into it. So I do that, then I take the absolute value that makes it positive no matter what it was. And then I do the operations outside. So I have -2, -4, 0, 0, and 2, -4. This graph opens down, but it is a V again. So if you had only picked 0, 2, and 4 as points, you would only see this, and you know there's a problem because absolute value should be a V, not a line. So then you know you have to find more points to see where the V is. Let's take a look at letter F. I'm going to pick my table and I'm going to pick values of -2, 0, 2, and 4. And I picked those intentionally. When I plug them in, I'm going to do everything inside there. So I've got -2 minus 2, which is -4. And the absolute value of -4 is +4. I've got 0 minus 2, that's the absolute value of -2, which is 2. 2 minus 2 is 0, the absolute value of 0 is 0. 4 minus 2 is 2, the absolute value of 2 is 2. In this problem, because I only have an absolute value symbol, everything should turn out positive. But if I had a negative number multiplied by it, or if I had a subtraction of something, then it is possible for the numbers to turn out negative. So I'm going to plot these. I have -2, 4, 0, 2, 2, 0, and 4, 2. I'm going to take those points and connect them to show the V and to show that the V continues going even beyond the points that I chose to plot. Any questions so far about graphing absolute value? Now, some of you are like, well, there's 8 this way and 8 this way. Potentially, I could be graphing 16 points or making a table of 16 points to find out where the graph is. You don't need to do that many points. You actually could probably even do one less than this, get away with three or 4 points. But you'd have to know where to start your graph. So look carefully at letter F. Look at this minimum point is actually called the vertex. And on the graph up here, it's also called the vertex. There's a minimum point. And even here, there's a maximum point called the vertex. Look at where those are at and look at the equation and see if you see anything that stands out. As you look at those graphs and you look at the equation, look and see if you see anything any patterns. So when I look at where this is, right, this is at -1, 1, and I look at my equation. This one's at 0, 0, and I look at my equation. This vertex is at 2, 0, and I look at my equation. Anybody notice anything about the equation versus where the vertex is? Let's take a look at the x-coordinates in particular. The x-coordinate on this one is -1. That's where my vertex was. Okay? Look at the equation. Yeah, I see a +1 there. I see a -1 there. Let's take a look at this one. There's nothing outside here, but my vertex still ended up at an x-coordinate of 2. And I look at the equation. Here I look at this one, and I don't have any addition or subtraction inside or outside, and my x was a 0. Does anyone see a pattern now? Rachel.
I don't know if this is right, but the x-coordinate is always, like, the x-coordinate is
Yes.
the opposite of the absolute value.
Yep. So when there's addition or subtraction inside the absolute value, the x-coordinate is the opposite. So if I see x minus 2, then the vertex, which is where I should really center my table, I should find something to the left and something to the right to figure out how wide those arrows are. But the center of it, the vertex, is going to be the opposite of what I see in the absolute value. So that may help you as you make your table. Look at this one. The opposite of 1 is -1, and that's where our vertex was. This one didn't have a plus or minus. Where is it? Right there. And so it was just 0. So a note that you may want to make when you're graphing or doing a table for absolute value is that whatever is the opposite of what you see in the parentheses, as long as it's a plus or a minus in there, whatever number this is, you're going to center your table at the opposite value. You're going to center your table at the opposite value. So what if I have -3 absolute value of x? Where would I center my table? There's nothing in there, right? So where's it going to be centered at then? 0, right? Is that what you're going to say, Max? All right. What if I have -2 absolute value of x minus 5? Where am I going to center my table? At 5. I'd make the center of my table at x equals 5 because that's where the vertex will be. And then I just need a point to the left of 5 and to the right of 5 to help me get the rest of that line, or those lines for the V. Any questions on how to do this with the table? All right. We're going to talk then a little bit about independent versus dependent variable. They're not always this case, but a lot of times they are. Independent versus dependent variable. The independent variable is which one, x or y? X. The dependent variable is y, and that's because we can write y as a function of x. As a function of x. We'll talk about functions a little more in depth later, but operations that happen to x help us get our answer for y. A linear equation, there's a couple ways to write a linear equation. One of the forms is ax plus by equals c, where a and b are coefficients, and c is a constant. It's just a number. Okay, that's used a lot in applications when you're totaling things up. It's used in business. It's used in economics, it's used in other sciences where I have multiple variables and they each have their own coefficient. Sometimes it's more than 2. Right now we're only working with 2 variables, x and y, and then they add up to a constant. The other type, and somebody mentioned this in my other class, is something that you've seen before, y equals mx plus b. There's also point slope form where it's y minus y sub 1 equals m times x minus x sub 1. It's another version of it. We'll get to all of these, reviewing all of these. We'll primarily use this one as we do our geometry. Except when we're graphing, sometimes we have it in this form. When we're graphing, it could actually be in any form, but y equals mx plus b, and this, which is called standard form, are the most common. Where is the x-intercept located? On the x-axis. It is on the x-axis, and it is where the value of y, or the height, is 0. Located where y equals 0, where we have a height of 0. Where's the y-intercept located?
Where x is 0.
It's on the y-axis, and that's where x is 0. So there's another way to graph some of these, and I know a lot of you are like, well, let's just do y equals mx plus b, but it actually saves you from having to even solve the equation. Okay? So we're going to look at just the linear first, and then we'll look at the other ones, because we will want to solve those. If I'm going to make, so let's say I want to find my x-intercept, what do I have to do? Well, I'm going to make my y what? Let y equal 0. In doing that, what happens to the 3y? It becomes 0. So there's something called cover-up method. Rather than writing this out as 4x plus 3 and then in parentheses 0 equals 12 and solving, I can just, because 3 times 0 is 0, cover up that variable, and the rest of the equation is what I write down to solve. 4x equals 12. Now I'm still solving for x, so divide both sides by 4. And that gives me x equals 3. That was when y equals 0. So my x-intercept is 3, 0 as an ordered pair. To find my y-intercept, I'm going to let x equal 0. So if I cover up the x variable, because 4 times 0 is 0, then I have 3y equals 12. Divide both sides by 3, y equals 4. So this, as an ordered pair, is 0, 4. I have my y-intercept, I have my x-intercept. I could graph, I only need 2 points, so if I were graphing this, I could actually plot 3, 0, and 0, 4 and connect to my line and be done. Don't have to make a table. Don't even have to solve for y in terms of getting it by itself with the other variables still there. I'd like you to try this for letter A. And I should have probably had to try it for letter E instead, because it's not always the other number that's in here, but we'll just do A for now. Try letter A. See if you can get the x-intercept and the y-intercept. Questions so far? If you did this right, when you went to find the x-intercept, you should have had 2x equals 10. So you should have got an x-intercept of 5, so 5, 0. When you plugged in 0 for x, you should have had negative 5y equals 10. So that would give you a y-intercept of negative 2. Would anyone like to see either one of those worked out? Okay, so those are our x and y intercepts. Now, is that going to work out so nicely for letter C? No, I mean it will for the x-intercept, right? Because now I've got 4x equals -8. For my x-intercept, I would have, when y equals 0, I'd have 4x equals -8. So that's not so bad. For my y-intercept, where x equals 0, I'd have this equation, 0 equals 2y minus 8. I can still solve that equation, but it's not as nice. I don't just get to divide. So I have to add 8 before I can divide. So if you cover it up and it's gone on one complete side of the equation, then that 0 that's left there, 4 times 0 is 0. So just be aware of that they're not always written in standard form. All right, any questions on graphing using the x and y intercepts? Because we're going to be asked to find the x and y intercepts and graph using those. All right, now for x and y intercepts, for this, the same idea. It's nice to do the x-intercept. I can't just cover up though, okay? So when I go to find the x-intercept, I have to make y 0. So that's going to be 0 equals the absolute value of x plus 1 minus 1. So how many answers do I have to an absolute value equation? 2 or 2 or none. Okay. So I'm checking. I'm trying to get the absolute value symbol by itself. I'm going to add 1 to both sides. 1 equals the absolute value of x plus 1. At this point, we separate it into 2 equations because the absolute value is positive. It will have 2 solutions. X plus 1 equals 1, or x plus 1 equals -1. By subtracting 1 from both sides on this one, I get x equals 0. By subtracting 1 from both sides on this one, I get x equals -2. So there are, in fact, 2 x-intercepts, 0, 0, and 0, -2. My x-intercepts are 0, 0, and not 0, sorry, 0, 0, and -2, 0. Because the x-coordinate, those are my numbers for my x-coordinates when my y-coordinate was 0. To find my y-intercept, I plug 0 in for x. Well, the absolute value of 1 is 1, minus 1 is 0. So this is also 0, 0. When one of your intercepts is 0, 0, like your x or your y, then the other one will be. But for this particular case, there's another x-intercept, so we have to find them both.
So like if there wasn't another x1, you would know right away it's 0, 0?
I would what? Sorry. Bless you. If there wasn't another x1, then I would just have, so if it wasn't an absolute value equation and one of them was 0, 0, then the other one would also be 0, 0. Yeah. All right, we're going to change the letter f a little bit. I'm going to make it -2 times the absolute value of x minus 2 equals y. And I'm going to ask you what we should do first. Who can tell me what we should do first?
I just have a question.
Yes.
How do you know when there's 2 answers for the absolute value?
So there will always be 2 answers for absolute value, like when we were solving, as long as when I have it by itself, like I've gotten rid of all multiplication and addition and subtraction, the number on the other side is positive. If I have this and the number on the other side is negative, then there's no solution.
Okay.
So what that would mean is, here's my x-axis, and the absolute value graph is either above or below the graph. That's why I don't have an x-intercepts. So we have the y-axis, or no, where are we? So here we have this one. What should I do first if I'm solving for my x-intercepts? I'm going to plug in 0, right? To find my x-intercepts, I plug in 0. I have 0 equals -2 times the absolute value of x minus 2. What do I need to get rid of first? The -2. How am I going to do that? Divide by -2. What's 0 divided by -2? 0. So now it looks the same. So don't be confused just because you see a negative on top of it. We've solved these before. Now, because this is equal to 0, it is possible that absolute value could be 0, right?
Yeah.
But it's not possible for it to be negative. So we want it to be 0 or bigger, ideally positive, but it could be 0. It just can't be negative. So if x minus 2 equals 0, or the opposite, Well, what's the opposite of 0? Nothing, just 0. So it's the same equation. So when I add 2, I get x equals 2. Does this one have 2 solutions? No. I would have split it, but because it was 0, it just has 1. So this is 2, 0 for my x-intercept when I go to graph it. Yes?
The question was y equals x minus 2. How'd you get the extra negative 2?
He changed the equation.
I changed the equation. I asked you guys to change the equation. Okay? Now when I go to find my y-intercept, I'm going to plug in 0 for x. So I have negative 2 times the absolute value of 0 minus 2. And so that's going to give me, this is going to be a 2 here. Positive 2 comes out of the absolute value, and then I multiply it by negative 2 to get 4. So my y-intercept is 0, 4. So that it is possible to have only one x-intercept, and that's because both of these would give us the same answer. When you go to solve an absolute value equation, you're expecting 2 answers, or none if it's no solution. There is the case that it is possible to get 1, but that's because it was equal to 0.
So it could be 2, 1, or 0.
Yep. But usually for absolute value, you're expecting 2. But it is possibly to be 1 or none.
If there is 1,
Mm-hmm.
does that mean that that is the minimum point?
So that, yes, that would be the vertex. So I'm either going to have a graph where the vertex is sitting right on the x-axis, or where it's opening up or down if I went to graph it. All right, we're going to come back to this later for the sake of time. Are there questions, though, on this stuff first? Did you have a question?
Oh, no.
Did you have an observation? No, I thought you had to raise your hand. That's okay. We'll come back to this later. Right now I want to talk about identifying whether it is linear. That should be pretty easy, right? We have 3 choices here. You have left, middle, or right. How many, show me on your hands, how many are linear? Show me with your fingers. There are how many that are linear equations? Some of you have 2 fingers up, some of you have 1. There are 2 linear equations because the other one is what? Absolute value. And I told you we're not doing any other ones other than linear and absolute value for now. But I can see that this is a linear equation in standard form. There's a coefficient times x, a coefficient times y, and a constant. And there's a sign between them. They're added or subtracted. And this one's y equals mx plus b. So they want us to find the x and y intercepts to graph the equation. So for this one, I'm just going to use the x and, like they say, find the x and y intercepts. So I'm going to do the x-intercept first. So I let y equal 0. And letting y equal 0, that leaves me with negative 7, or no, sorry, 3x equals 21, because my y goes away. So I'm left with 3x equals 21. Divide by 3, x equals 7. So my ordered pair is 7, 0. And I can plot that on my x-axis. For my y-intercept, I'm going to let x equal 0. So when I cover up that, I get negative 7y equals 21. Divide both sides by negative 7. Get or y equals negative 3. So now my y-intercept is 0, negative 3. And I can plot that. And that right there is enough points to give me my line without having to make a table. Just make sure you put arrows on the ends when you go past the graph. Any questions on that one? All right, yes?
How did you get x equals 0?
I made x equals 0. Okay? So when you're finding the intercepts, to find the y-intercept, you make x equals 0. Right? Because it's going to be 0 something for on the if you're on the x or if you're on the y-axis, x is 0, so 0 something. And if you're on the x-axis, y is 0. So this is where I'm letting y equals 0. This is where I'm letting x equal 0.
Oh, I thought that was a final equation.
No, no, no. I am making that to find the y-intercept. So this is my point, and that's my other point. Yes?
Can you solve the one next to it with the absolute value?
Yep, that's what we're going to do right now. So this next one we're going to solve, and you're like, oh my goodness, that looks crazy. Well, if you want, you can get y by itself first, but it's not going to really matter because, again, if I want to find my x-intercepts, what am I going to do? Plug in, yeah, make y 0, let y equal 0. In doing this, this gives me the opposite of the absolute value of x plus 3 minus 2 equals, well, that's 0 plus 2, so it's 2. So this is just like some problems that were on the quiz, and that we did before we took the quiz yesterday. To solve this, I need to add 2 to both sides. So I now have 4 over here. Now I have the absolute value of x plus, I can't write today. The opposite of the absolute value of x plus 3 equals 4. What do I need to do now? Divide by -1. So now I have x plus absolute value of x plus 3 equals -4. So what do I know? There is no solution, which means there is no x-intercept. Now I can still find the y-intercept, but is that going to give me my absolute value equation? So what am I going to have to do to make this equation, be able to graph it? Because of this, it is going to graph. It has a graph, but to graph this, I'm going to need to do what? Make a table. Even if I had the x-intercepts, so I know for this one, by the way, where should the middle of my table be if I'm going to make a table for this one? Where should the middle of my table be? Look at the equation carefully. What number should I pick for the middle? Not 2. -3. See, here's my absolute value symbol. Here's what's inside. So I'm going to pick -3 for the middle of my table. Then I might pick a point or 2 to the left and a point or 2 to the right of it to plug into the function. Okay, and then I can get my table and graph that. Questions on that? All right, so let's do that real quick. If I plug 0 in, I've got the absolute value of 3. I'm going to show the work up here. I have negative. This is absolute value of 3 minus 2. This is one for 0, for when I'm plugging 0 in. Equals y plus 2. So that's going to be 3. Take the negative. That's -5 equals y plus 2. If you want, you could solve for y first. That might make it easier. I'm going to subtract 2. I get y equals -7. So when x is 0, y is -7. That's actually our y-intercept, which is one of the things we were asked to find. So I was able to find that and plot it. Now I'm going to plug in the -3. What's going to happen when I plug -3 in here? What happens in there? That becomes 0. So if I do that, when x equals -3, I've got the opposite of 0, -2 equals y plus 2. I subtract 2 from both sides, and I get y equals -4. Because over here I have -2 minus 2. So I've got -4 for my y-coordinate. Let me get a piece of paper just to do the other one so you can see it a little more clearly. I'm going to put in -5, so I have absolute value of -5 plus 3 minus 2 equals y plus 2. The -5 plus 3 is -2. The absolute value of that is 2, but I have this negative on it. So that means that I have -2 minus 2, which is -4. And when I subtract 2, I get y equals -6. So in my table, I say when x is -5, y is no, that's not right. Yes? What's your question?
For when you input -3 for x, won't y equal 4, like positive 4?
It does. It is positive 4, isn't it?
Yeah.
Hold on, I gotta look at it.
Because you would add to so it's
Oh, because I'm adding to it instead of subtracting. Got it.
Yeah.
So this is positive 4?
Yeah.
Okay. I'll go back and show that one in a second. And this one is -6. Let me go back and do the -3. I didn't show it very well. Negative 3 plus 3 minus 2 equals y plus 2. This is 0, so that's gone. I have negative 2 equals y plus 2. I'm still getting negative 4.
You have to add 2 and then add 2 to the y. Oh wait, no.
I have to subtract 2 from both sides, which is negative 4. It is negative 4. That's going to be negative 4. So let's look at this. We know this is our vertex. Negative 3, 1, 2, 3. Negative 4, 1, 2, 3, 4. Which actually, if it's positive 4, then I have a problem. I want this to be negative 4, and there's a reason why. That was negative 3. So negative 5 is supposed to be negative 7, right? 1, 2, 3, 4, 5. No, 0. 0 is negative 7. Negative 5 should be negative 6. This is the graph I have. This graph should make more sense than if I had this being a positive 4y. What didn't I have that forced me to make the table? Yes? I didn't have x-intercepts, so it had better be down here if it's going to be pointing down, because I'm not supposed to have x-intercepts. That's why we had to make the table for it. All right, our last concept for today.
Can you put the words for negative 5x back on?
Yeah, for negative 5, right there. I'm going to leave that there for a second while I end this video to make another clip. So hold on one second. Stop.